right, let's just jump right in. What if I told you that the engine of our modern world, the code that moves all our money, flies our planes, and gets you your social security check, isn't sleek or new? What if it was actually written before the internet as we know it even existed? Well, that's exactly the wild idea we're going to unpack today.
I mean, really let that sink in for a second. We're so used to thinking that in technology, the new thing always comes along and just completely demolishes the old thing. But the truth is, the most critical, load-bearing parts of our digital world are built on foundations that were laid decades ago.
And look, this unseen foundation isn't made of dusty old relics. A better way to think about them is like digital cathedrals. These massive, incredibly durable structures built for one thing: reliability. They're still doing their job perfectly, day in and day out, while newer, flashier buildings rise and fall all around them.
The scale here is, well, it's almost impossible to get your head around. A staggering 80%, that's 80, of all financial transactions on the entire planet still flow through systems written in COBOL. Yeah, that supposedly dead language that outlived disco, but still keeps the global economy humming along.
And it's not just about money. These systems are everywhere. They are the financial arteries, they're the backbone of our government, the lifelines in our healthcare systems, and the networks that run all our transportation. We're not just talking about technical debt here. We are literally talking about the load-bearing walls of modern civilization.
The numbers are they're mind-boggling. Just look at this. JPMorgan Chase is running on over 200 million lines of this code. Meanwhile, American Airlines system, Sabre, is handling 500 million, with a B, flight searches every single day. This is the staggering, invisible scale we're dealing with.
And this is the question everyone asks, right? It's the logical next step. If they're so old, why don't we just, build new ones? It sounds so simple on the surface, but the reality is that the whole Silicon Valley mantra of move fast and break things just completely shatters when it comes up against this kind of critical infrastructure.
Yeah, replacement is pretty much a fantasy for a few huge reasons. First, the cost is just astronomical. The FBI famously burned through $170 million on a project that completely failed. Then there's the catastrophic risk. A single bug could literally freeze the global financial system. And then you've got what I'd call knowledge archaeology. Decades of undocumented business rules that are nearly impossible to piece back together. And finally, these systems are tangled in this massive web, connected to thousands of other systems that all depend on them to work.
So, if a total rip and replace is off the table, what about the great disruptor everyone's talking about? Blockchain. This is the technology that promises all the things these old systems struggle with, like transparency, security, and trust, especially when you have lots of different organizations trying to work together. So, in simple terms, a blockchain is just a shared, unchangeable digital ledger, and its promise is incredibly powerful. Trust the mathematics, not the institution. In a world where we've seen institutions fail us, think Enron, think Wells Fargo, that is a very, very compelling pitch.
This slide really gets to the heart of the conflict. It shows the fundamental difference in what these two things were built for. Legacy systems, our cathedrals, are designed for absolute, bulletproof reliability inside one organization. Blockchain, the network, is built for mathematical trust between many different parties. They're solving totally different problems, and that leads to very different strengths and weaknesses.
And right here is one of blockchain's biggest hurdles: raw performance. The Visa network, a classic legacy system, can chew through 65,000 transactions every second. The Ethereum network? About 15. That performance gap is just enormous, and it's a huge reason why you can't just swap one for the other. Which brings us to what the future actually looks like. It's not some epic battle to the death between the old and the new. It's not a revolution. It's an evolution. The real innovation, the truly clever work, is in building bridges between these two worlds.
So, how do you actually build this bridge in the real world? Well, it's done with a few smart strategies. First, there's something called API translation, which basically wraps these old systems in a modern interface so they can talk to new applications. Then you have things like event-driven architecture, which helps these old batch processing giants communicate in real time. The real key, though, is selective deployment. You only use blockchain where it adds clear, specific value. And now you've even got AI tools that can read old COBOL and help translate it, creating that seamless connection.
And hey, this isn't just theory, it is already happening out there. Just look at this. You can see how huge players like JPMorgan and Walmart are combining the strengths of both worlds. They use their super reliable legacy systems for all the core stuff, but then they strategically add a blockchain layer for very specific tasks, like super secure payments or tracing food for safety. It's the perfect example of using the right tool for the right job.
But you know what? Maybe the biggest challenge here isn't technical at all. It's human. You've essentially got two completely different cultures trying to build this bridge together. You have the monks who are guarding the cathedrals, and you have the mathematicians who are designing the new networks. On one side, you have what you could call the COBOL priesthood. These are programmers who've spent decades making sure these systems never ever fail. They've seen countless tech fads come and go. On the other side, you have the blockchain evangelists, who are all about decentralization and moving fast. I mean, they speak different languages, and they have fundamentally different views of the world.
So bridging this chasm, it takes more than just technical interfaces. It demands human ones. Things like cross-training programs, actually documenting all that hidden knowledge, and creating shared vocabularies. These things are absolutely essential. Because at the end of the day, the technology can't work if the people building it can't even communicate with each other.
This quote just perfectly captures the essence of this whole evolution. A palimpsest, if you don't know, is an old manuscript where the original writing was scraped off so something new could be written on top. But faint traces of the original always remain. We aren't erasing our digital history. We're writing the next chapter directly on top of it. And that creates a much richer, more layered, and stronger system.
So ultimately, this leaves us with a pretty profound question about progress itself. The story of our digital world seems to suggest that the most resilient and powerful future isn't about demolition and replacement. It's about synthesis, and it's about having respect for the foundations that, whether we see them or not, are still holding everything up.